There are several reasons why relational databases are like this. Let's focus on two of the most important ones. First, orders and accounts are different types of objects and will be easier to organize if kept separate. Second, this multi-table structure allows queries to execute more quickly. Let's look at each of these points more closely. The accounts and orders tables store fundamentally different types of objects. Parch and Posey probably only wants one account per company, and they want it to be up to date with the latest information. Orders, on the other hand, are likely to stay the same once they are entered, and certainly once they're filled. A given customer might have multiple orders, and rather than change a past order, Parch and Posey might just add a new one. Because these objects operate differently, it makes sense for them to live in different tables. Another reason accounts and orders might be stored separately has to do with the speed at which databases can modify data. When you write a query, its execution speed depends on the amount of data you're asking the database to read and the number and type of calculations you're asking it to make. Imagine a world where the account names and addresses are added into the orders table. This means the table would have 6 additional columns, 1 for account name and 5 that make up the street address, city, state, zip code, and country. Let's say a customer changes their address. In this world, the 5 address columns need to be updated retroactively for every single order. This means 5 updates times the number of orders that they've made. By contrast, keeping account details in a separate table makes this only a total of 5 updates. The larger the dataset, the more that this matters. There are more reasons for this kind of structure, but for now, what you really need to know is how to connect the account data and order data. The mechanism for doing that is a join, which you'll learn next.